Hello guys, today we are going to make a custom IP for GPIO control. We'll be controlling this LED, Jaipu board LED with the switch. We are making custom IP. This will this LED will control by these switches, right? So we will have to interface. We will be making an IP in which there will be the switch, which will be the four input switch and the four output. Basically, we will make IP as a reconfigurable, parameterizable, right? Uh, we can use this IP even in Z board and other board as well. So we'll be making parameterizable IP. Okay, guys. So without doing any delay, I am going to create an IP. So I'm going to share my screen, guys. So I will try to cover it up as soon as possible. Okay. So for this, we are going to create. First of all, we are going to create an IP. For this, you need to go to tools. Okay, guys, you need to go to tools and create and package new IP. Okay, in these options, you have to go. So you have to select create XI for peripheral. You have to check these options. There are so many options, but for we are creating XI for peripheral IP. So just click on next. You have to give the IP, your IP name. Let's suppose I'm taking LED control IP. So version this. So description SWI switches control LED. Okay, guys. So I'm saving. So I have to keep the directory name. Okay, so I'm saving this IP repository. I'm creating the new folder LED. So I'm giving IP. Okay, guys. So LED control IP, I have given the name. Select this. Next, you have to show. Here you have the basic interface where for our purpose we are using XI Lite. You can use XI full and stream as well, and the data bus. Data bus is 32-bit by default. A number of register. So basically two register will be enough for us. One for the switches and another for the LED. Okay, but by default we are taking four registers. Okay, guys. So now I'm just clicking to the next and I'm checking the options edit IP so that we will be able to edit whenever there is requirement we'll be able to edit this IP. Okay guys, so just I'm going to finish. It will create the new project. Okay, it will create the uh, new project. So this project will contain some Verilog file and XML file. Okay, guys. So till then, we'll be waiting. Initializing the project. So we need to wait here till the new project open. Okay guys, so here you can see here is new project has opened now. So as you can see here, new project has been opened. So guys, here you can see there's a Verilog file, right? Here's a Verilog file dot v LED file, and this is the component dot xml file. This file contain this window, right? So we are just giving the vendor name. Let's take Othos Technology. Othos Technology dot vendor name so switches is used to control LED. Okay, that's fine for me right now. So it is the compatibility. You can use Zynq. So here you can add any device family to support this IP, right? So for we have just added Zynq. So in file group, you can see here is the Verilog file, instantiation file, and this is a software driver file. We'll be making some driver file as well here. We'll be creating, right? See, identity control.h and see by default it has made the subdriver, but we'll be making our own driver, right? To control it. Okay, guys. So initially you have not seen any port that deals for switches and LED port interface. As you can see, there is no port, right? So in the GUI view as well, you can see there is no port here. So we need to have a switch and LED ports, right? So for this, we have to just we need to some modify some environment code. Okay, guys. So we are going to modify it. So first of all, we are going to create some ports here. User port you can add here. So you can add here. So input. So we'll be having for this we are going to make a parameterize. So we are writing here parameter switch. That's the blue IT switch switches with just simple switch with let's suppose we're taking 8 here and parameter with okay guys here okay so we're using this variable because we are making the parameter right so -1 0 now this is the LEDs and output this is the input so this will be the switches okay guys so we're just here okay here's a colon so I'm going to just copy this file control C output control A here so I'm just deleting it okay so this is the LED width control C control B and this is the LEDs this is connected with LEDs okay guys so now we are going to port map so first of all we have to have parameter dot okay dot switches with okay so this is the parameter mapping here it's dot LEDs and with LED width okay guys So here is switches WID. This is not here. Switch and LED. Here switch and LED. Switches, right? Switch. This is the switch and LED. So this is the parameter mapping is done. Now we're going to map the port map. Switches, connected switches, okay, and the LED is connected with the LEDs. So now this file is done. So we are going to another inside this component. Here is the port map, as you can see here. LED control beyond yes slave exit, right? So we are just going to add this input in the LED control exit parameters. So here also we need to define the ports. Guys, user ports here, and also you need to add those parameter as well. You need to add here. So we have it parameter also. Okay, guys. Now here you can see. So we are going to define a function right now. So we are going to connect with the register 0 with the output LED and the register 2 with the switches, right? So how can you do this? So for this you have to just sign it, okay? So here you can say assign, right? Here is a sign statement, so you can write assign LEDs to LEDs is equal to raise 1, slave raise 1. Okay, guys, we are directly connected with the slave raise 1. Okay, now slave raise 1 we have connected this. So here you can see for the right function. For right function, let me show you functions here. The right and read enable. Here is the right function, right? Slave raise write enable. This is the write enable signal. Whenever this signal is high, then depending upon the address, it will write. Depending upon the address, it will write on the corresponding address value. So for the slave 0, this is fine for slave 0 because we are writing to the LEDs, right? So the second address, this is the first second register. So we are not going to use this anymore. We just comment it out. Okay, guys, you have to just comment out this. Comment out this. We'll be using another files. Okay, slave raise one you can comment it out. Okay, guys, so now you can comment this out. Right, so we're going to use this always block. Use this always block. It's Control C. Another always block here. So exit block reset slave raise 1. Okay, guys, the reset is high, then this is begin and okay. Else begin else begin and and if is right enable. Okay, then you can add the function slave raise one. So we are going to connect the switches with the slave raise one. So for this, we need to do here switches 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 the next time we will do. Okay, guys. So I'm going to right. So here we need to pass slave raise one the switches. Switches is connected with this module and begin the process. Okay, guys. So now we can done done this modification. We have connected switches with the register one and the LEDs with the rest. We have connected registers in the register 0 with the LEDs and the register 1 with the switches. Okay, guys. So now we are going to save this file. So we are going to save this file on mind. Now you can see here. So I just close this. Now we can happen. So guys, we have just added our IP. Just we have created the LED control. This IP is not reflected. You can see here there should be switches and LED, right? So here it is not reflected. So is this things port switches and switches and LED. Switches and LEDs. Okay. This is not so LEDs average. Average. Select rate 0. system boot interface. This is what you things library also. Okay, replace IP catalog. So that just delete this and read on this if there is any upgrade in the status. There is any upgrade. So, upgrade. So setting, setting. And control is already added here. So so we have LED control version 1. LED. Now you are able to see, right? Okay, guys, so we are going to add the processors part, Zynq processors. This Zynq processors. Let me add the processor first. Just hold on for a moment. So processing system is also added. Now automation. Okay, just click on OK. Okay, guys, it is connected DDR. I need to fix the IO pins of the gyro board. So again, we need to connection automation. So yeah, you have to just click on OK. So it will connect the XI interface to the processor. I needed to connect the manual this port LEDs and make it external. Okay, guys, so we have to make the switch also make it external. So I have to specify the constraint file for the LED and the switches. Okay. So guys, uh, now we have to validate the design to check if there is any error. So here is showing some parameterizing error. Okay, so if it is it's shown like that, then again you need to optimize it again, validate the design. So whenever you revalidate the design, you validate the any other. Okay, guys, so it's a result. So we have to just go to the source, create the wrapper file and run the project. Okay, so here's our project. So we need to create the wrapper, HTML wrapper. HTML wrapper file. Hold for some moment. So I have created the wrapper file LED control PS wrapper. Okay. Okay, guys, we have created. Now we need to generate. It's operating right now, so we need to generate output log as well. So we have to click on this and we can click on the generate output product. Okay. Generate the output product. Generating the output products, and we'll synthesize our design as well. Just use so moment. So I'm stopping. So guys, I'm going to share my screen again. Okay. So we have already set our stone and switch design. So we have set our LED control PS as a top, right? So after synthesis, we have to constant this LED and the switches. So I'm going to do the synthesis. I'm going to synthesis my design. After synthesizing, our design will be assigning pin. Will be assigning pin of this LED and the switches. I'm just pausing my video till synthesis is done. So guys, synthesis is done. So synthesis is done right now. So we are going to open our synthesis design. Okay, so we are going to open synthesis design. So here you can see our planning window is open, but here is 8 LEDs and the 8 switches. But in the Zygo board, there are the 4 LED and the 4 switches only. So we did one mistakes. So we need to go to this file again. So we have to change because we have made it parameterizable, right? So we have to make it 4-bit, and LED also we have to make it 4-bit so that okay guys, so because we have 4 bits only, So we need to again recompile it. We did some mistakes. As you can see here, you can be able to see. Let me show you. Here are the 8 LEDs, right? So you have to make this to 4 LED, 3 down to 0, and this will also 3 down to 0. 3 down to 0, guys. Okay. So to make this, either you can delete it. Yeah, so better we need to delete and we add. Okay, guys. So better we're going to delete this line and we're going to make external again. Just Control T. Just place Control T to make it external. Okay, guys. So we have made it. Now again we need to recompile this, validate and recompile it. Just wait a moment. So here you can see the address of our device, right? This is the 43C0. This is our slave GPIO, right? This is our GPIO. This is our LED control IP, which is 43C0, right? Okay, so now just validate and save this design. So we have to just right. So we need to recompile this thing again. Okay, guys. So we have to set the block design and this interface so that there will be the four ports for the LED and the four ports for the switches. Okay. Till then, I am going to stop screen share. So synthesis is done right now. So I'm going to go to the project again. So here synthesis is complete, guys, right? So synthesis complete. You can see here now. I'm going to open our synthesis design. Okay, I'm going to open it. So here you can see. Let me show you. This is the look, the design, because we have made the changes. It's loading the netlist because in previous there are the 8 inputs and output arrays. Okay. So now you can see here there is a only two input switches and the four output LEDs. Okay, so we are going to put map it. I think code must be mapped already, so because I had already written some constant file. So for the LEDs, there are the D18, G14, M15, and M14. It's already mapped here. And for the switches, for switches that is T16, W13, P15, and Z13. Z13, G15, right? So constant is already written over here. So we have to just save it, and we need to run the implementation. After implementing the design, we'll be generating the beta stream. Then we'll be writing some driver file for the LED controls or our LED controls IP. Okay, guys. So it's initializing the design. Till then, I am going to stop. I'm going to stop my recording so that video shouldn't have to be so long. Okay. So guys, implementation is done right now. Okay, implementation is done here. So we are going to generate the bit file finally. Okay. So we are going to generate the bit file. It will take 1, 2, 3, 4. After completion of the bit file, we will be launching an HTML and we'll be writing some driver code. Oh, no. Okay, guys, now video stream is done. So we are going to launch the SDK. So our video stream is done here. So set. So we're just closing the syntax design. Just hold on. So here we are going to export hardware into stream. Now we are going to launch the SDK, guys. Okay, we are just launching SDK. Okay, now we are going to write driver code, guys. Okay, so importing it is importing hard and hardware. We'll be waiting here. Okay, guys, so we are here LED control PS wrapper. So this is the SDF file which contain all the hardwares, right? LED control, this is the slave, our slave, or its address is the 43C0. Okay, guys, so now we are going to create the LED controls and empty project, application project. Okay, so let's give name LED. Yes. Okay, standalone. So the platform is LED control wrapper. Okay, so next we have to just recommend the empty application. going to write the driver file. So wait a moment. Okay, guys, LED control PS were just created an application here. See the control the PS system. So here's the source empty folder. So we have to write some header file. Let's give a name. Header file. Header file name. Let's give LED control.h. Okay, guys. So another file we are going to create here is source file. LED name should be the same. Control.c. Another file we'll be creating here is this is the source file. LED test. C. Here we'll be basically creating the three files. Okay, guys. So now we are going to write one by one. So here, this is the we are writing the definition of the function. So we have to just include zero types dot h. Okay, guys. So another we need to include field file. So this file include all the types definition, which structure type. So we are defining the structure here. So you can write like this struct LED control. Let's give a name LED control. Okay. So this is the structure name, but standard method is you can write type def struct LED control. Okay. So this structure file contain separate structure contain because we are writing and reading. So we need the base address. So just u 22 bit base address Okay, guys. So this is right control. This is the handle of the structure. Okay, so we are going to write some initialization function. Initialization. Okay, so end is slides. Okay, so which will contain some pointer type variable. Okay, so where we'll be passing two variable here. So one is the LED control pointer my LED, and another will be the base address 32. Okay, guys, so this will be the base address. Base address will be passing here inside this function. So we'll be writing. Okay, so we'll be writing my LED. My LED, so we'll be passing the base address to base address. We are passing return 0. Right. So another function will be for the for writing to the function write write data write data, so it will also consume, it will also take the two variables and u32 write data, right? Write data. Okay, guys, so here we'll be writing some data. My LED this address. Write data. Okay, guys, so another function will be the reading. U32 will be reading the data. Okay, guys, so here's the my LED will be taking one variable. So here we are going to read. So for reading, what we can do here is just to so so here for writing the data, we need to xilinx function out base address. Okay, this is the right data. Function closed. Okay, guys, let me take it out here. Right data. So yes, right data. Read switch. Right LED read switch. Okay, so we are reading to the switch. For this we have to write the function xilinx in else. Base address plus 4. So this is the function we have written here. Set here drill out base address plus 4, fill out right data. Okay. So here, so this is the .h file. We are just copy all these folders, all this file onto C. Now we are just C. So .h file, .h file. Just include .h file. Function as it is here, and we just have to function just enable function file. Just remove the function definition from this file. Okay, just save it. Okay, so now we are in the final stage. LED test.s file. LED test.s file. We have to include the file boundary. So first file will be including include LED control.h. So here the structure name LED control, right? Just copy and just LED control here. Variable type my LED. So we're writing, we're writing to the function for first of all we need to initialize the function, right? So for initialization, we have to call this function. This function just function LED. So just okay, my LED. So base address will be get the base address from here. One, writing right. This is the pointer to the function. Save. This is done. GPIO. GPIO address. GPIO. Here's the base address. Control C. Let's, paste the base address. Set. Here's the semicolon. That's the thing. Set none. It's more done. Yes, we have. So right now, what we are going to do is it's done. That's right. This is and done. So what we are going to do, guys, because we are going to make our IP for third party as well. So for this, you have to delete all the. We have to delete. Okay, so what you have to do is just go to STK, right? You have to go to the project. First of all, you need to delete. We have to go to the drivers folder, source. You need to delete the ch file and text file. All three files you need to delete this file. Just delete it. Now we need to go to the D folder. And here you will be able to say that is the project folder. You need to go here to go to the SDK LED PS. PS, right? So it's the source file. Signal as file. Just going to just copy this file and paste this file. Just transfer this file. Okay, so copy it and then paste this file to our final drivers folders source folder. Paste this file to and save it. Okay, so almost we are done right now. So you will be able to see here. So please, so we're getting some problem here file groups because we just deleted controls. We're going to some file from here. Just going to remove this file. And add the files. Let's try it. Just adding this file. But here again, here you are seeing whenever you deliver this IP to other guys, this will cause the problem because there's the source locations, right? So in other driver file, there is the from driver LED control V1. So we have to add on the drivers slash LED. So how can we do that? So for this, we have to just package this. Just it's been modified. Package it. Okay, guys, so you need to open that XML file. To go back here, to go back now to open this .xml file. Right. source first, control D, source first, D/folder, right? So here you have to delete all the things. Okay. Please, stay so okay, so I have to save this file, close it. Be able to see here. Say package it. Close this. Again, open it. File groups. Software. Storage. Closing an issue. Answer D. Sense. Can you do this and still and here? So that's why using successfully. Yes. Since it's fine. this. File groups. First one, right? You can say just mouse this. Okay, now all set. We have to repackage it. Okay, done. Okay, guys, now we are going to use this IP. This IP catalog. So we are going to program on PC. We are going to connect this FPGA. We are connected now. We are connected now. We are going to just close things. Sticky file. Okay. Test. This is our program. This one is our program. So right now we are going to program FPGA first of all. So platform is LED control. PS factor. So we are going to program the FPGA part is program. Configuration. So platform is LED control PS. Wrapper bit. Says the standalone application developer. And then PS and negative control PS store. Okay, so that's all. Apply it. So 100%. This is this is here is something problem, right? So it is not some mistake, I guess. Mistake. So we'll be resolving it tomorrow.